This question says, use the remainder theorem to find the remainder when this polynomial p of x is divided by some linear expression. Right, before we even look at the second bit, let's try and do those first two parts. So, it would be helpful to state the remainder theorem. And the remainder theorem says that when a polynomial p of x is divided by some factor x minus a, then the remainder is p of a. So just the polynomial evaluated at whatever the value of a is. So let's try and use that. So it says use the remainder theorem to find the remainder when this polynomial that we've being given this specific example, is divided by, in the first case, x plus 1. So if x plus 1 was thought of as x minus a would be minus 1. So we need to find p of minus 1. Right then, so let's substitute minus 1 into this cubic. So I'll have minus 1 cubed minus 1 squared plus 2 lots of minus 1 minus 2, which is minus 1 minus 1 minus 2 minus 2, which is minus 6. So we can say p of x divided by x plus 1 has remainder minus 6. Right, the second part, exactly the same process, but now x minus a in this example will be x minus 1. So a would be 1. So we're going to do p of 1 now, evaluate the polynomial when x is equal to 1. And that's going to be 1 cubed minus 1 squared plus 2 lots of 1 minus 2, which is 1 minus 1 plus 2 minus 2, which is 0. So p of x divided by x minus 1 has remainder 0. Okay, the next part, it says hence state a factor of p of x, then write p of x as a product of one linear and one quadratic factor. Well, the two remainders that we've got are minus 6 and 0 in the two cases that we looked at. If the remainder is 0, that means that it divides exactly. So we can say that x minus 1 is a factor since p of 1 equals 0. So that's now using the factor theorem, which is a special case of the remainder theorem. Okay, so we've got one factor, and it would like us to write p of x as a product of one linear and one quadratic factor. So let's write p of x out as x cubed minus x squared plus 2x minus 2, and let's try and get the quadratic factor by reverse multiplication. So we're suggesting that our cubic polynomial is the product of x minus 1 and some quadratic factor. So x times something gives me x cubed, so it must start with x squared. Then I've got minus x squared giving me minus x squared, which tells me that the other contribution to the x squared term over here would come from x times whatever the x term is here, so it must be 0x in this quadratic factor. And finally, we've got to make 2x, so to get at the constant term, we've got minus 1 times 0x, which is 0x, and then we've got x times the constant, which is going to be the only contribution, so it must therefore be plus 2. Because we've reached the constant, we have to close the bracket. Just to double check that we've got the correct constant over here, and it all makes sense. Minus 1 times plus 2 gives me minus 2, so that's okay. Right, and we should just write it without the 0x, so we can say that therefore p of x is equal to x minus 1 times x squared plus 2. It's now written as a product of a linear factor and a quadratic factor. It's worth just saying that this quadratic factor can't be separated into two other linear factors with real coefficients. Sometimes it could be, but in this case it can't. We could work out the discriminant to check, and we'd find that the discriminant was negative.